Okay, so the next part we're going to cover is about transpose and inverses. So let me just write down these two matrices. So suppose we have A, 2, 3, 7, 9. This is a matrix. And we have B, which it doesn't have to be a square matrix. 2, 9, 6, 8, 0, 4. So we have these two matrices. And this is a 2 by 2 matrix. This is a 2 by 3 matrix. So let's start with transpose. Now the transpose of A, which can be written as AT or A prime, they both mean the same thing. So the first thing we do is we flip the dimension. So the row become column and the column become row. So for a 2 by 2 matrix, a square matrix, that doesn't matter. But over here, what we would have is that instead of a 2 by 3 matrix, we have a 3 by 2 matrix. So the transpose of B, which can be written as BT or B prime, is going to become a 3 by 2 matrix, and this will be a 2 by 2 matrix. And all that we do is we flip the rows and the columns. So the first row is 2, 3. That is going to become the first column. And the second row is 7, 9. That is become the first column. The second column. Same thing with B. We have 2, 9, 6. That becomes 2, 9, 6, 8, 0, 4, 8, 0, 4. And that is a transpose. So you can construct matrices of any dimension. There's no restrictions, and you can construct its transpose. Some of you may have already used the transpose function in Excel. It's effectively when you have a row and you want to convert it into a column, or when you have a column and you want to convert it to a row. And this is effectively what's happening, is we're flipping the rows and the columns. So transposes have a few properties. All right, so this is transpose. So properties. Okay, so the first property of a transpose is that if we have a matrix, we take its transpose, and then we take its transpose again. Okay, so this doesn't need to be so big. Transpose again. We get the matrix back. And that should be obvious. If we take this and we take its transpose again, we'll go back to A. Similarly, if we take this and take a transpose again, we'll go back to B. It's very easily verifiable. The second property is if we add two matrices and we take its transpose, that is the same as adding the transposes of the two matrices. So of course, we cannot add A and B because they're not of the same dimension, but you guys can create two random matrices of the same dimension and try and do this. Add them and then take the transpose, or take the transposes and then add them, and you should get the same thing. And the third property is if we are multiplying A with B and then taking a transpose, that is the same as this. Okay, so this may not seem as obvious as the first two properties, but once again, just come up with any two random matrices A and B that conform so that you can multiply A and B, and then do this, and what you should see is that they give you the same answer. So these are the three properties of transpose. And once again, in the next video, I'm going to